Hey everyone, and welcome to The Explainer. Today we're actually going to count down 10 absolutely mind-blowing facts about one of the strangest, most perplexing dinosaurs ever pulled from the Earth. We're heading back to the lush, ancient wetlands of the Early Cretaceous to uncover a creature that has literally forced paleontologists to hit pause and completely rethink what predatory dinosaurs actually looked like. So picture this. Imagine an apex predator, but it's mashed together with the features of a shark, a camel, and, believe it or not, a bird. I know, it sounds like some made-up mythical chimera, right? But roughly 130 million years ago, a dinosaur with exactly this bizarre combination of traits was actually stalking the Earth. Well, meet Concavenator Corcovatus. It's this incredible 130-million-year-old mystery that has totally fascinated and honestly kind of baffled paleontologists ever since it was discovered. I mean, one look at this animal and you immediately know you're not dealing with your standard run-of-the-mill theropod. Let's break down exactly what makes this creature so incredible, fact by fact.
All right, Chapter 1, The Hunter of Cuenca.
Starting off with fact number 1, there's actually this really funny media mix-up early on. Some early reports, like one from the Ecuador Times, confidently claimed the fossil was found in Cuenca, Ecuador. But looking at the actual scientific records, it was definitely unearthed at the Las Hoyas fossil site in the Cuenca province of Spain. That specific region is part of the La Juerguina Formation, which, back in the Barremian stage of the early Cretaceous, was this vibrant, lush, subtropical wetland. Moving on to fact 2, and it's all about that wild name. Concavenator Corcovatus literally translates to the hunchback concave hunter. The genus name, Concavenator, combines the Latin word conca, pointing to the Cuenca province, and venator, which means hunter. Then you have the species name, Corcovatus, which translates straight to hunchbacked. It is a highly literal name for a truly unbelievable animal.
Chapter 2, The Bizarre Back Hump. Let's get into the weird stuff.
Coming in at fact number 3, we're going to look at the exact bones that make up this unique spinal structure, because it's actually super unusual. You know how Spinosaurus has that massive, continuous sail running all the way down its back? Or Acrocanthosaurus with its uniformly tall spines? Well, Concavenator is totally different. Its sharp, triangular hump is formed by just 2 extremely tall vertebrae right in front of its hips. Specifically, it's the 11th and 12th dorsal vertebrae. They jut out about twice as far from the body as the rest of the spine, so it's this really short, abrupt, and highly distinctive crest. Which brings us to fact 4. What on earth was this hump actually for? Scientists are still hotly debating this, because when you find a weird structure like this, you have to ask what evolutionary advantage it gave the animal. The Spanish team who discovered it thought it might be for thermoregulation, controlling body heat, kind of like a solar panel. Other experts, like researchers over at Cambridge, suggested it was a visual display for recognizing other concavenators or attracting mates. And, most intriguingly, some think it might have been used to store fat, helping the dinosaurs survive long periods without food. For fact 5, we're looking at a really great point brought up by the community over on the paleontology subreddit. People there accurately pointed out that unlike modern camels or bison, where the hump is mostly just soft, fatty tissue sitting over a normal spine, Concavenator had a very distinct bony ridge. Now, sure, it might have been heavily covered in fat or thick muscle, but the skeleton itself undeniably formed a rigid, triangular core. It wasn't just a fleshy lump. All right, Chapter 3, The Feather Debate. Fact number 6 is where things get really crazy. It's about a totally shocking discovery located right on the dinosaur's forearm bones. Get this, paleontologists found these tiny ulnar bumps on Concavenator's forearm that look exactly like the quill knobs you see on modern birds. In today's flying birds, and even in closely related theropods like Velociraptor, those knobs act as anchor points for the ligaments that hold large flight feathers. Finding them on Concavenator was absolutely mind-blowing. Why? Because this guy was a Carcharodorsaurid, a dinosaur family way, way distant from the group that eventually evolved into birds. If these were actually for feathers, it means feather-like structures existed way earlier and across totally different dinosaur family trees than we ever thought. But as always in science, there's another side to the story. Fact 7 is all about the debate. Some researchers argue those bumps aren't for feathers at all. Earlier studies suggested they might just be intermuscular lines for attaching tendons. Later on, researcher Elena Cuesta-Fidalgo and her team took a deep dive into the forearm musculature. They found that if it wasn't a quill knob, the only muscle that could realistically attach there is the M. onconius muscle. The catch? That muscle normally attaches to a smooth surface, not to bumpy ridges. So the debate is still raging. Are these true quill knobs proving early feathers, or just a really, really weird muscle scar? Both sides honestly make incredibly compelling arguments based on the fossils we have. Chapter 4. Built for the Kittle. Fact number 8 gives us a look at the sheer physical stats of this predator. So looking at the numbers, it measured about 6 meters, that's roughly 20 feet long, and weighed in at around 500 kilograms. Now, yes, it was definitely smaller than its later massive cousins like Giganotosaurus, but whatever it lacked in giant size, it more than made up for in pure agility. Because it had these relatively long shin bones compared to its thigh bones, experts estimate Concavenator could hit top speeds of around 35 kilometers per hour. That made it perfectly adapted for sprinting after prey in those ancient wetlands. Fact 9 reveals its lethal toolkit. I mean, it's a Carcharodontosaurid, who literally means shark-toothed lizard, and it absolutely lived up to the name. It had these flat blade-like teeth lined with tiny, vicious serrations. These weren't thick, bone-crushing teeth like a T-Rex had. These were specialized tools. They are meant for fast, repeated slashing bites designed to quickly bleed out large prey. On top of that, unlike a lot of later massive predators whose arms shrank to almost nothing, Concavenator had these really powerful three-fingered grasping arms tipped with curved claws, perfect for grappling and holding on to violently struggling prey. Chapter 5. A perfectly preserved world. And that brings us to our final fact, number 10, which is all about the miraculous circumstances that even allowed us to find this fossil today. The reason we know all this insane detail is because Concavenator was found in a Conservatlagerstätte. It's a fancy German term for a fossil site with absolutely exceptional preservation. Basically, the animal died in a shallow wetland and was very quickly covered by these slimy microbial mats. Those microscopic mats literally locked the body in place before it could rot or get torn apart by scavengers, eventually encasing the whole thing in limestone over millions of years. Because of that, we didn't just get the bones, we got actual impressions of its soft tissue. We literally have physical evidence of wide, rectangular scales on the underside of its tail, and even bird-like scoots and fleshy pads on the bottoms of its feet. It is incredible. So, with this crazy mosaic of features, from the scaly foot pads and the shark-like teeth to that rigid bony hump and those highly debated quill knobs on its arms, it really leaves you wondering, if we magically found a living Concavenator today, what would it actually look like? Would it look like a giant, scaly reptile, a bizarre, oversized, flightless bird, or something completely alien to anything alive right now? Will we ever truly unlock the complete visual mystery of the hunchbacked hunter of Cuenca? Keep questioning, keep learning, and I'll catch you in the next explainer.